Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping back into an 8th grade topic, geometric dilations, with a focus on negative scale factors. Now, if you're new to my channel, I put timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. At the end of this video, I will put a link to my 8th grade playlist in which I cover a ton more topics, so if you're interested in that, make sure you stay tuned. As always, if you have any questions about what we see today, or even on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 2 parts, so leave a like, smash subscribe, and let's get started. In my first video on geometric dilations, we discussed what a scale factor was, and we talked about the 4 ranges that your scale factor will most likely fall into. Now, if you hadn't seen my first video on this topic, you can find it right up here. Check it out at any point in time. However, in that video, we discussed the following 4 ranges. If you recall, we talked about how a scale factor can be greater than 1, it can be equal to 1, it can be between 0 and 1, and it can be 0. Now, we also talked about how we don't focus on these 2 because it really doesn't tell us anything new about our graph. We're going to either stay the same or go away, and that doesn't really help us when talking about dilations. However, if you look at this, you see that something's missing. We don't have any negative numbers. And it might make you think, is it possible to have negative scale factors? Well, the short answer is yes. You can have a negative scale factor. That's just going to result in something that's a different type of dilation, a special type of dilation. Now, I call it special because your regular dilations are not going to change orientation. However, whenever you have a negative scale factor, that's going to result in a dilation that does affect the orientation as well as the size of your shape. So before we jump into why it works, let's talk about how it works. And we're going to focus on geometric dilations that are centered at the origin. That's going to make things a lot simpler for us, so we're going to start there. Since we're going to be centered at the origin, we're going to be able to make use of our wonderful shortcut when talking about geometric dilations. And if you recall, that is simply applying your scale factor to your point. So let's say you had a scale factor of 2, and you had a point x, comma, y. This is our original point P. Well, if we apply our scale factor to our point P, we're going to get something like this. P prime is going to be 2x, comma, 2y. That is because we're centered at the origin. Well, what if we had a scale factor that was negative 2, and we still had this point x, y? How is our P prime looking now? Well, the good news is you do the same exact thing. You're going to apply that negative 2 to both your x and y, so you're going to have a negative 2x and a negative 2y. But why does it work? We know we're doing the same exact thing that we are doing when we have a positive scale factor, but our dilation is going to change the orientation somehow. And the reason for that is whenever you have a dilation with a negative scale factor, you're really doing not just a simple dilation, but a combination of 2 different transformations. So whenever you have a dilation with a scale factor that's negative, you're really doing a combination of a dilation and a rotation of 180 degrees. So let's once again back up to how it worked. We showed that if you did a dilation with a negative 2 scale factor, your point is going to look like this. However, you can break this up into 2 separate steps. Your first step, or it doesn't really matter what order it goes in, but your first step is simply doing your 2, your absolute value here, and applying it to, it's not going to be directly P prime, so I'm going to say like P bar or whatever. And that's going to be 2x and 2y. So this can be your dilation step. Matter of fact, let's call this PD for dilation. And your PR is going to be your negative xy, right? Negative x, negative y, and that's going to be your rotation step of 180 degrees. It's important that you do 180 degrees. Now, where does this come from? If you don't remember what we talked about in our rotation video, you can check it out right up here. I'll have a link there and you can see exactly what you may have missed or forgotten. However, this is a shortcut that we discussed in that video whenever you have a rotation that's centered at the origin and you're doing 180 degrees. So each individual transformation tells us to do something to this point, and when we put it together, we get our final product of a dilation with a negative scale factor. So you see that whenever you have a negative scale factor, you're not really doing a pure dilation. So technically, this is not a dilation problem. You're really doing a combo between a dilation and a rotation. So let's see how this works with one example. And let's make sure that we are getting what we're expecting from a dilation and a rotation on your graph. So let's say we have this example here in which we have the triangle ABC and we have a scale factor of -3. We're once again doing a dilation centered at the origin. So we're going to have an origin-centered dilation. And we just said that we're going to apply our scale factor the same exact way because we are centered at that origin. However, what are we expecting our overall graph to look like? Well, this -3 means that we're going to be doing a dilation and a rotation. And because it's a 3, we expect it to be bigger than what we have here. And because it's negative, that means we're expecting a 180-degree rotation. Now we're starting in quadrant 1, and we talked about whenever you have a 180-degree rotation from quadrant 1, you're going to end up in this third quadrant here. So the end result that we should be expecting is a bigger graph in this third quadrant, and it may have a different orientation. So let's see if we get that by applying our scale factor directly to A, B, and C. Well, the first thing we have to do is find A, B, and C. So A is going to be 1, 3. B is going to be 2, 1. And C is going to be 3, 2. And if we apply our scale factor of -3 to our 3 points, we're going to get an A prime, a B prime, and a C prime that look as follows. So what's -3 times 1? That's going to be a -3. And a -3 times 3 is going to be a -9. How about a -3 times 2? That's going to be a -6. -3 times 1, -3. -3 times 3, -9, and -3 times 2, -6. So let's plot all 3 of these points and see what type of transformation we are looking at. So now that we've got all 3 points and we've connected our dots, let's see, does this graph fall into what we expected our end result to be? Are we in quadrant 3? Yes. Is our graph bigger than our original graph? Yes. So it seems like this scale factor of -3 is indeed acting as we expect, both doing a dilation and an 180-degree rotation. This is no simple dilation, but it is indeed a combo between 2 different types of transformations. So I hope you're following today's examples, and I hope you see just how special your dilations with negative scale factors truly are. However, if you have any questions about what we saw today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.